Hi guys. All right, we're back with lesson 2, session 2. We're talking about unit rates using fractions and ratios. Now, I'm not gonna lie, ratios are like not my favorite thing. Like, I am so excited to be done with this lesson. I don't know. Fractions are fine. I love adding, multiplying, subtracting, dividing fractions. It's just I don't like dealing with ratios and fractions. So knowing that your teacher doesn't really care for it, just keep that in mind, that this doesn't have to be fun. It kind of sucks, I'm not gonna lie, but we can get through it. We'll get through it nice and quick. We only have a few pages to do together today, and then hopefully we can try to finish this lesson quickly. I think there's only 2 more sessions. So let's go ahead and get right on into it, okay? So Julio and Kyle are taking a hike along the same trail. Kyle hikes for 6 miles in 2 hours. There's kind of like a ratio right there, right? So for every 6 miles, he went 2 hours. We could say miles per hour and do 6 per 2, like that. Miles per hour. Okay. And then we gotta look at the iPhone over here. It says Julio hikes the first half mile in a fourth of an hour. So he went 1/2 miles per 1/4 hour. Okay. Who hikes more quickly? Well, it's kind of hard to compare these two things because for one, shorter distance versus longer distance and longer versus shorter hour. So let's go ahead and make a little number line, okay? Let's go ahead and make a number line. This is going to be Julio. I'm going to put a J for Julio, okay? So Julio went 0 miles, new number line, and he went 0 hours, right? That just makes sense. He didn't go anywhere, time hadn't started. We know that Julio does go in 2 hours. He went 6 miles. Dang, Julio. I feel like we're missing some information here. Oh, no, I'm looking at the wrong person. I was looking at Kyle. Sorry, my bad. Okay, Julio hikes the first half mile. So here's the half mile. And in a half of a mile, he goes 1/4 of an hour. At that rate, if this was 1 mile, this would be 2/4 of an hour, 2/4, which is the same thing as 1/2. And if this was another half, so this would be 1 1/2 miles. That means Julio would have gone, let's see, that'd be 3/4 of an hour, because we're just going up by fourths, right? Which would make this guy, 2 miles, be 1 hour. Okay, I can work with that a lot easier, right? Let's do Kyle. Kyle's going to be in red. Same thing. He went 0 miles per 0 hours. Okay. Kyle goes 6 miles in 2 hours. If I split that in half, that means he went 3 miles in 1 hour. Now do I kind of have a unit rate here going on? Can I see per 1 hour and per 3? Okay, so what that means is in 1 hour, it takes Julio, to go 2 miles, it takes Julio 1 hour. To go 3 miles, it takes Kyle 1 hour. So who is fastest? Mr. Kyle. And the reason why we know that is because we made a unit rate, okay? We just made number lines until we found a unit rate. Now, is that like a good idea? Can you guys just make number lines for everything? Probably not. It's a great strategy for now, but we'll learn like the mathematical way to do that as well. The mathematical way would be like taking 6 divided by 2 and getting 3, and then find Julio's ratio, which would be taking a half divided by a fourth. Half divided by fourth equals 2, right? So 3 and then 2. There are ways that we can do this mathematically that'll make more sense. We'll figure that out in a second though, okay? So here they're showing the model it. That's basically what we literally just did. But now let's talk about the mathematical way to do this. So as we said, you can take Julio's speed and Kyle's speed. and you can divide them, right? And then you can get 3 and you can get 2. We'll figure that out. We'll talk about more of that in a second. So look at the model it. Okay. The first model it, which is these number lines exactly like what we just did right here. Who hikes more quickly? And how can you use that double number line to figure out who's hiking more quickly? Okay, so we know that Kyle's hiking more quickly. Whoa. Kyle. Okay, so we know it's Kyle. And the reason why we know that is because on these number lines, we looked at the unit rate. The unit rate was 1 hour, 1 hour, and we can compare how far they went each at an hour. You can compare how far they each went in an hour. What is Julio's speed in hours per mile? Explain how you can use the double number line to find Julio's speed in hours per mile. Okay, hours per mile for Julio, what they're basically saying is in 1 mile, how fast does he go? In 1 mile, he goes half hour. That sounds silly, but it is. In 1 mile, wait, did I say mile right? Yeah, 1 mile, he goes it takes half hour. 1 mile equals 1/2 hour. Look at the second model it. The fraction 1/2 divided by 1/4 describes Julio's speed in miles per hour. What fraction describes Julio's speed in hours per mile? Just flip them around, silly gooses. Just go 1/4 divided by 1/2. Okay? If you flip them, then you're going to get hours per mile versus miles per hour. Now, which one makes more sense? Miles per hour for sure. Okay? That's all we're going to put. That's literally all you have to do. But then if we had to actually solve it, what would we do? We take 1/4 and we would divide it by 1/2. You skip it, you flip it, and you multiply. Skip it, so it's 1/4. You flip it, so it's 2/1, and you multiply. 2 times 1 is 2. 4 times 1 is 4. Equals 1/2. Woohoo! Exactly what we got right here. Who'd have thought? Okay. Silly. The fraction 6 divided by 2 describes Kyle's speed in miles per hour. What fraction would Kyle's speed be in hours per mile? Once again, just flip it. 2/6. 2/6 can actually be reduced, can't it? Divide that by 2, and you get 1/3. So he can go 1/3 hour for every 1 mile. Do you need a different strategy to find speed because one involves fractions? Explain. Well, no. You just flip them, okay? You just flip the fractions. If you want to go miles per hour, then you do miles divided by hour. If you want to go hours per mile, then you go hours divided by miles. Ugh. I hate that. Miles per hour is the right way. Don't go hours per mile. That's silly. Okay. What did you guys like better? Reflect. Which of these model strategies was one that would help you better understand how to solve a triad problem? Would you prefer to make a number line like this? Or would you prefer to do it mathematically with dividing fractions? To me, I think it depends on the problem, honestly. Some problems I know how to do it real quick with just dividing. Sometimes I'd rather just see it visually. But tell me, go and pause the video, tell me right here, what do you guys prefer? All right, apply it. A penguin walks south. It completes the first 3rd mile in 1/5 hour and continues walking at that same rate. What's the penguin's speed in miles per hour? Okay, so if that's miles per means divide, per means divide, per means divide. Okay, sorry, I got really excited there. Miles, see, miles per hour. So we're going to take 1/3 divided by 1/5, and we are going to skip, flip, and multiply. So we skip it, we flip it, and we multiply. 3 times 1 is 5. Oh, 5 times 1, I mean. 3 times 1 is 3. 5/3. Ugh, that makes a really ugly fraction. 5/3 is the same as 1 2/3. How do I know that? How on earth do I know that? Do you guys remember? Do you guys remember how to make an improper fraction into a mixed fraction? Okay, how you do that is you ask yourself, how many times can 3 go into 5 by multiplying without going over? It can only go in there once, so I'm going to make a big 1. Now, what is 3 times 3? Because we can only do it once, right? Or 3 times 1? 3. So, we take our leftover. How many is left over? 2. And then we keep the denominator the same. That's how we can switch improper fractions into mixed numbers. Okay, you gotta remember that. Super important. Number 8. A maple tree shades an area of 7.5 meters squared. Ooh, remember that's squared because it's area. In a scale drawing, the maple tree shades an area of 12.5 centimeters squared. In the scale drawing, how many square centimeters represent 1 meter squared? Ooh, this is a weird question. Okay, well, first of all, I don't like to work with mixed numbers when multiplying and dividing fractions because icky, it does not work. So first of all, we got to turn these mixed numbers into improper fractions, just like what we did up here, but backwards, okay? So 7.5, we times and add, okay? So 7 times 2 is 14, plus 1 more is 15, and then keep the denominator. So that's equal to 15 halves. And then we times, we add, 12 times 2 is 24, plus 1 more is 25. Keep the denominator. Okay, now we can actually do something about this. Now that I have fractions I can work with, let's take 25 halves and divide it by 15 halves. Okay, now how do we divide by fractions? Well, we skip it, and then we flip it, and then we multiply. 25 times 2 is 50. 15 times 2 is 30. Now that is a big old fraction, but did you know that if you have zeros and they lined up nicely and there's nothing else behind them, you can just cross them out? Whoopsh. 5/3. B. All right, last problem. Dahlia is mixing paste. For every 1 2/3 cup of water, she uses 2.5 cups of flour. Okay, so 1 2/3 cup of water. We could say it's 2.5 cups per 1 2/3 of water, right? How much flour does Dahlia need to make each cup of water? So let's take, I guess we could just take water divided by flour. It really doesn't matter. So let's take water, 1 2/3, divided by 2 1/2. Now, if you know anything about what I just said up here on question 8, is you cannot multiply and divide fractions if they are in mixed fraction form. We have to change them back, okay? Remember, you times, plus. And then we go over here, we go times, plus. So you times these two, that's a 3, plus the 2, that's a 5, and then you keep the denominator the same. So then you times the 2, that's a 4, then you add the 1, that's a 5, and then you keep the denominator the same. Now I can divide. How do you divide fractions? You skip it, you flip it, and you multiply. 5 times 2 is 10, 5 times 3 is 15, 10 15ths, I bet we can reduce. Let's go ahead and divide by 5 on each of these, because we can take a 5 out and get a 2 and a 3. Aha! So Dahlia, whatever her name is, she needs 2/3 cup of flour. Ew, flour does not start with a P. Per 1 cup of water. Okay? Easy cheesy, lemon squeezy. Basically, what I want you to get out of this lesson is 2 things. 1, skip, flip, and multiply. That's how you divide fractions. Skip it, you flip it, you multiply. The other thing I want you to get out of this lesson is you cannot divide or multiply fractions until you change them back into improper, okay? Remember, it's times plus. Times plus, okay? All right, guys, we will do page 41 and 42 in class together. See you later.